Alright, let me go over number 5. This is on the back page of review worksheet number trig unit, review worksheet number 3. Okay, so we're trying to sketch a graph for sine of 2x. First thing we do is we find the derivative. So a derivative is simply going to be sine of u times u prime. So cosine of 2x times 2. So we set the derivative equal to 0. Divide both sides by 2. I'm going to switch it to the other side here. Take the inverse cosine of 0. So cosine of 0 will occur at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. I'm listing out more than I need because I have to divide by 2 and see which falls within our interval from 0 to pi. So divide everything by 2, I get pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And the only values that will work will be between the intervals will be at pi over 4 and 3 pi over 4. So we put that on the sine line. Okay, here we can choose a value between 0 and pi over 4 to test to see whether each of these intervals are positive or negative. So we plug into the derivative, first derivative. If I choose a value between 0 and pi over 4, I can choose pi over 6. So pi over 6 in for the x. So 2 times pi over 6 using pi over 3. Cosine pi over 3 is positive value times 2. That's a positive. Here I can choose a value between pi over 4 and 3 pi over 4. So I can choose pi over 2. So pi over 2. 2 times pi over 2 is pi. So cosine of pi is simply negative 1. Negative 1 times 2 is negative. Between 3 pi over 4 and pi, I can choose 5 pi over 6. So 2 times 5 pi over 6 is 10 pi over 6, which reduces to 5 pi over 3. So cosine 5 pi over 3 is a positive. Cosine in the fourth quadrant is positive, times 2 is positive. Okay. We know at pi over 4 there's going to be a relative maximum. So to find the y value, we have to plug pi over 4 back into the original equation, right? The original equation tells us the y value. So pi over 4 in for the x. So 2 times pi over 4 is pi over 2, so sine of pi over 2 is simply 1. Okay, 3 pi over 4 will give us 2 times 3 pi over 4, which will be 3 pi over 2, so sine of 3 pi over 2 is negative 1. Okay, so we have a relative minimum here and relative max here. Sorry, relative min here and relative max. Second derivative, cosine of u becomes negative sine of u times u prime, so negative sine of 2x times 2 times the original 2, so negative 4. Okay, so then we set our second derivative equal to 0. So sine of 2x equals 0, 2x equals inverse sine of 0. Sine is going to be equal to 0 at 0, pi, 2 pi, 3 pi. Divide each term by x, and I get 0, pi over 2, pi, and 3 pi over 2. 3 pi over 2 is definitely out of our interval. And only pi over 2 is going to be between, so we're going to have pi over 2 as our potential point of inflection. Okay. Choose a value between 0 and pi over 2. I can choose pi over 4. So pi over 4 into the second derivative will give me 2 times pi over 4, which is pi over 2. Sine of pi over 2 is 1. 1 times negative 4 is negative. Here I can choose a value between pi over 2 and pi. Let's say 2 pi over 3. So 2 pi over 3 times 2 is 4 pi over 3. Sine of 4 pi over 3 is negative, because that's in the third quadrant. Negative times negative is positive, so concave up. Okay. And then pi over 2 back to the original function, because I know that this is going to be a point of inflection. There's a change in concavity, so plug pi over 2 back to the original function. Sine of 2 times pi over 2, this will give me pi, so sine of pi is simply 0. Okay. Relative minimum, we found the order pair, the reason being a prime changes from negative to positive. Relative max at pi over 4 and 1, because that prime changes from positive to negative. Point of inflection, we know because f double prime changes signs. Concave up from pi over 2 to pi, because f double prime is positive. Concave down from 0 to pi over 2, because f double prime is negative. And we also want to plug endpoints into the original function, and plug 0 into the original function. I get sine of 0, which is 0, and then sine of 2 times 0 is sine of 2 pi is still going to be 0. Okay. We can plot the order points, the y values order pairs onto our graph, and then follow the curvature for our sine, for our increase, decrease, as well as our concavity, and we can follow the graph through. Alright, so increase, concave down, decrease, concave down, decreasing, concave up, increasing, concave up.